So basically what we want to be able to do is that we want to use the relational database as our storage mechanism, right? We want to be using techniques like we saw last week about using JPA to be able to interact with the web service, but it's backed by a JPA data model. So the same data model we looked at last week, right, with the users and faculty and students and courses and section, right? So we created that data model already. We want to be able to expose that to folks that might want to retrieve all this information, right? We already created the data models last week. We created users with usernames, password, and whatnot. We converted them into entities, yes? We also created faculties and students to make them inherit from the base user. We created repositories last week, yes? So all that we did with JPA, so we're not going to do that again. JPA created the schema for us. We inserted a couple of users in there. We had some queries for retrieving using usernames and passwords and whatnot. We played around with that. So last week, the way we tested this was using JUnit, yes? We were running it right here from the command line. So a more interesting way to interact with this is to expose it as web services. Okay? You know, for instance, we want to retrieve a particular user. Okay? So ideally, we could use a get mapping where we have /user/ the ID of the user that we might know. And that would retrieve that particular user. Now internally, we could use the user repository to do that, right? The user repository has a find by ID, right? So we can certainly do that and parse from the path the user ID, passes as an integer, and then use that as an argument for our repository. Okay? And same thing with retrieving all the users, right? Where you might use the repository find all to retrieve all the users. Notice here that we are prepending /API. See that? We are prepending /API. What's that? Well, notice that /user is the actual entity that we're interacting with, the table, the class that we're interacting with. Yes? /API is also part of convention that tries to deal with the fact that your server will typically be doing lots of different things, right? One of the things typically that it will be doing is hosting some website, right, that has a static content such as HTML, CSS, and JavaScript, and images, and all sorts of static content. Static from the server's point of view, right? These are just ASCII files, right? They're sending over to some client, some browser. Make sense? But it's also going to be providing dynamic data. Right? All this that we're generating here, right? All these web services allows us to retrieve arrays of users, right? Arrays of courses, allows you to create new courses, right? And then respond with a new set of courses. So all this is dynamic data, okay? So we want to be able to distinguish between these distinct use cases for the server. The same server is doing two things, right? It's hosting static content, right, in the form of ASCII files and images and sound, whatnot, yes, and video. But it's also hosting or being able to retrieve data that is dynamic, that is encoded either on XML or Java or CSV files or whatever. It's all dynamically generated. So to be able to distinguish between the two, we need to come up with a convention, right, and say, you know, everything that is data related, I'm going to prepend with this with this particular token, right? So that I know that everything that lives on the /API, right, it's all going to be just data, right? So that I don't mistakenly add a folder, a physical folder called API, and put some content in there. You know, but that would go against this whole endeavor. So yeah, so /API is a very common naming convention. /REST is also very common. /data is also very common. But /API is by far the most common, right? And what it does is that it captures the idea that we are interacting with some very well-defined API with posts and puts and deletes and whatnot, yes, with a particular URL, also that matches is following a criteria, right? There is a very, if we say REST, that says a lot. You know, just by saying REST, it says, you're following a particular set of conventions, right? I know what you're going to be doing. You're using post, get, delete, put for these, and the URL is going to have a particular structure. Make sense? Right? So it's an API. So / use it for retrieving all users. Let's see if we have some data here that we can play around with. Although I think I was getting some error messages here. Cannot add foreign key constraint. Ooh, I think it was trying to create an enrollment. That's fine. Let's see what we have so far. Do we have a, let's see, what database was this? Resources. So this is presumably being mapped by what? Let's see. It was an update, 5200. So database is JPA fall 2018. Let's see what we have there so far. So JPA fall 2018, very good. We have, what tables do we have? We have course. What do we have under there? There's our course, and presumably we just have a title. Okay, let's try and get that. Let's try and retrieve this. Let's do that. Let's go back here and let's create a service that would allow us to retrieve courses. And we already did that, right? Course. And right now it's being backed by this array list. So we don't want to do that. We don't want to do that. Instead, what we want is to use one of the repositories. So let's do that. So auto wired, just like we did in the unit test. And let's retrieve here the course repository. Course repository. And instead, so here this retrieve all courses, instead of retrieving this array, yeah, ideally what we would do is use the repository, course repository, and we do a find all. There it is. It's complaining. We need to cast this, so let's cast it. Cast. Hello. Cast. There we go. What about this this find by ID? Instead of using this for loop, right? We could use the repository again. We could do course repository dot find by ID. We can pass in the ID. And we're going to return that, return. So we don't need this return null. We'll need to, let's see, what do we need to do? We need to get. So we're going to be optimistic and assume that we know the correct ID. Well, that's dangerous, right? We would need to check to see if that ID actually exists. All right, so let's try that. Let's restart. Okay, let's go back to our Postman, and let's use the find all courses, and let's run that. Notice that indeed we're able to retrieve the CS5500, right? That it's in the database. Right? So we've effectively made available our data that was only available within our little enterprise. Right? Now we've wrapped it with a web service that would allow other folks to be able to integrate with us, right? As long as they pass in the correct MIME type, as long as they follow the API that we will make available and document and support, and folks will be able to integrate with us, right? Or retrieve. Let's see if we can create a couple more. So this is CS 5200, CS 5610, and CS 4500. And let's apply here. We'll say update. If we come back here and refresh, there we are. They're all there. Or if we know a particular ID, we can retrieve that ID and go to find course by ID and use that ID and retrieve 5610, retrieve 5500, or 5200. Make sense? All right. Okay. All right. So let's keep looking at a couple other things.